All right, so we're doing simultaneous equations today. So what that is, we needed to find the inverse. That's why we needed to learn about the inverse and the determinant to be able to solve simultaneous equations using matrices. So what you see is when we have simultaneous equations, so it's when we normally have, say, something like you have two equations. I don't know why I did that one, but anyway, you have two equations like that, and you want to solve, and as I said, it's when you've got the two lines and you're trying to solve where they cross. That's what you're doing when you're solving simultaneous equations. All right, so we're going to solve them using matrices. So what you do is you end up, first of all, you have to set up it in matrix form. And the way that you solve matrix form is you create this first matrix, and this first matrix ends up being all the numbers that are in front of the x and the y. So if you look here, I'm going to put the 2, the 3, the 2, and the 7. So in here, we'll go 2, 3, 2, and 7. Now you have to be careful that you're doing x's are under x's and y's are under y's. Okay, so that would be our first matrix. Then what we say is that we times it by, and this is where we put the letters that we don't know. So in my example here, I don't know x and I don't know y. Okay, so they're the ones. Now the order's important. If I've done, like before what I said, if I've done that x, y like that, it has to be x, y down like that. Okay, and then we'll say that it equals, and what we write as it equals is the answer to your equation. So you can see there that it's 5 and it's 8. So 5 and 8 are going to go into this one. So what we've done is we've set it up. That's setting up simultaneous equations in matrix form. That's how we do it. So if you look at it here, what we're saying now is we're going to pretend we have this matrix, and I'm going to call this matrix A, and we're timesing it by matrix X, and it equals, I'm just calling the last one the end one. I might call it B this time. Over here I've called it E for end, but it doesn't matter. So remember the other day when we talked about, we said if this was the one we didn't know and we wanted to solve for it, what would we do? We would move this A over the other side. Now, we remember if we were solving, that's timesing, so over the other side, I'd want to divide, but we don't divide by matrices, we use the inverse. So you can see how, and now because the A is at the front, I'll put the inverse of A at the front over there, and it'll be times B. So this is how we would solve it. So if we're going to go type it into our calculator, what we're going to have is you would type out that 2, 3, 2, 7. You'd raise it to the power of -1 and you times it by 5 and 8. And so what that's going to give you is the answer to the matrix X. So you're going to end up with a 2 by 2, and that's pretty much going to tell you X, and that tells you Y. So what you're actually finding is that X value and that Y value where those two lines crossed. So I'll show you on the calculator. I'm just going to pause iPad. Okay, so we've done it on the calculator, and we've got 1 point, I'm going to do it to 2 decimal places, so 3, 8 and 0.75 there. So that's what X and Y are for those. So you've solved it simultaneously. So sorry, just missing here, hopefully it's not missing on yours. So X equals the inverse matrix times the end matrix. So there I've explained it to you. Now if the determinant equals 0, so what we're talking about in our example, if the determinant of this matrix here, the 2, 3, 2 and 7, if that equaled 0, you would not be able to find the answer. There'd be no answer to the simultaneous equations, but this one's determinant didn't equal 0, did it? So if you look at it, its determinant would be 2 times 7 minus 3 times 2. So it's 14 minus 6, so it was 8. So that one did. If it equaled 0, you wouldn't be able to find the answer. It means there was no solution there. Alright, so flicking to the next page. Alright, so here we have an example of when we have 3 simultaneous equations. So if you have 3 unknowns, so my unknowns here are x, y, and z. Okay, if you have 3 unknowns, you're going to have 3 equations, and you're going to have to you'll set it up the same way but similar. So what we would do is we would set all the numbers that are in front of the letters into the matrix. So what that would mean would be these letters here. They will be numbers in your scenario. So what I would have there would be A, B, C, D, E, F, and G, H, I. That will most likely be numbers. So this would be the X, Y, and Z. So these are the numbers in front of X, Y, and Z. Then you would say you're timesing it, and you're going to times it by your unknowns, which were X, Y, Z. And then you'd say it equals what your answers were, which are these ones. Okay, so that's J, K, and L. All right, so then so this is, just to take note, write down a note, this is simultaneous equations set up in matrix form. Okay, so it's important because it depends what they're asking you. They might initially ask you just set it up in matrix form. So that's what you do. Now, if you're saying to solve in matrix form, and you have to show how it's done for that, that's when we will write it the other way. So we'll write X, Y, Z equals, and we'll have that C, D, E, F, G, H, I. We'll have that one to the power of -1 times that end one. Okay, so that's how you'd solve it. If they ask you to set up how it's solved, you would do it like this. Sometimes they ask you to have that actually calculated. So that's when you would actually show that in your calculator. So if you have a look over here, let's go do this example here. So if I was to set up in matrix form, I'm going to pop in all the numbers. So 3, 4, -2. Now X is 2, Y is 3. There's no Z, so I'm going to put a 0. There's 1 in front of X, 2 in front of Y, and 3 in front of Z. So make sure these are the numbers in front of the corresponding letters. And then I've got X, Y, Z in there, and then it equals -5, -1, and 3. Okay, so that's set up. If we are going to then solve in matrix form or whatever, the way we're going to say that it's solved is we're going to write X, Y, Z equals, and now I'm going to do the inverse here. So this is going to be that invert, like say that was A, this is going to be inverse A, but instead of writing to the power of 1, I'm actually going to type it in as what it is. Now if you look here, I typed it in the calculator, and then I've typed it. So what you're actually using is that one. So that's the inverse, where I've just done the inverse separately in a separate step, and I've put it there. And then I'll say, it's times by the end one, which was -5, -1, and 3. Okay, So that's how you would say you're going to solve it. And you might say this, just so you remember, this is, you're going to use this matrix. This matrix is pre-multiplying. So they just seem to use that word, and it seems to confuse kids. So if they said, what matrix do you use to pre-multiply to solve it, that's the matrix they're talking about. They want the inverse one. So if we went and did that on our calculator, so I'll go over and just do it with you. So this one is a 3 by 3. The calculator is very paused. Come on. Okay. All right. I'll pop in the original and show you how the inverse was that. So remember, you can tab, if you press the tab key, you go through the elements quicker. Okay. So if I raise that to the power of -1, okay, so there's the inverse. So what you're going to do, you would times that, it's actually that matrix. Now you can see I've pressed the up key. Someone was asking me the other day. Press the up key, see how it's blue? If I press enter, it's put it down there and I can use it. So then I wanted to times that one, and I want to times that one by a 3 by 1. And that then times it by what those simultaneous equations equaled, which was -5, -1, and 3. So here's my answer here. Okay, so that ends up being, sorry, click over here. What did I say? -11, 7, and 0. So what you're saying, because that's actually x, y, and z, what you're saying is x equals -11, y equals 7, and z equals 0. So that's the order of how solving it. So you're going to get these questions, you know, where someone got, you know, 3 people go to the shop and one orders a pie, a milkshake, and a cheeseburger or something like that, and then you have to work out the prices because they tell you how much they spend and all that. So we'll see that. Let's go and see a couple of examples. So here's some examples. The matrix equation below represents a pair of simultaneous equations. These simultaneous linear equations have no unique solution. So now this is where I said you've got to remember, when you see no unique solution, write the determinant has to equal 0. So, and their question is, what could m be if that happens? So what you do is you go over and you go, all right, so this determinant of this, the det of this matrix here, has to equal 0. So that means I can say 12 times 3 minus 9 times m equals 0. So I've got 36 minus 9m equals 0. And then you can either do it on your calculator. If you're not good at solving equations, that's fine. Just do solve, comma, m. And if you work out that, it's going to be m equals 4. Okay, so this linear equation has no unique solution, and it'll just be when m equals 4. So we'll pop that in there like that. All right, so here's what you got to, the way you solve it. So you probably thought, oh, I have no idea when you first read that. That's why the trick into doing things is when you see no unique solution, write what you know about that fact. If you write what you know, you'll then probably come to how to work it out. All right, so here's question 6. A worker can assemble 10 bookcases and 4 desks in 360 minutes, and then 8. So here's they're setting up those simultaneous equations. So I'm going to say 10 bookcase plus 4 desks equals 360, and the next one, 8 bookcases plus 3 desks in 280. Okay, if the bookcase takes B minutes to assemble and D minutes to assemble, the matrix BD is given to you. So they're saying like that. They're saying use those letters that you just used. So they're saying, how do you solve that? So if we set this up in simultaneous equations, it would be 10, 4, 8, 3 times BD equals 360, 280. But they want me to show you how do I solve that. So we know BD will equal the inverse of that one. So 10, 4, 8, 3 to the power of -1 times that end one. Okay, so what you're going to look is you want that. Now they've put this matrix here. They've done that. They've already done it in the inverse form. So straight away, get rid of ones that look like the 10, 4. That's not the inverse, yeah? So get rid of that. You know that's not working. This is definitely not right. It's not even in, who knows what they're doing there. So let's go onto the calculator and find the inverse of this matrix. Okay, so we did this in the calculator and we have seen that that is negative 1.5, 2, 4, and -5. So it is A is the answer because that's how you're working. Just be careful that this orders are correct as well, because they often muck them around and that could be a trap. Okay, so here we've got it state whether there is a unique solution for these simultaneous equations. So remember, if there's a unique solution, that means the determinant will not equal 0. So, because if it equals 0, there's no unique solution. So you really just have to work out the determinant of that front matrix that we have when we do simultaneous equations. So it would be that 2, 4, 3, and -6. So I've taken those numbers there. Okay, so you can see I've typed it in the calculator here, and I just stored it as A. You can do that, or you can still write, I could have put and a curly bracket and put the actual matrix, and it will find me the determinant. So because the determinant equals -24, there is a unique solution because that is not 0. All right, so let's do the next question. All right, so here's some more exam questions. The matrix equation below represents a system of simultaneous equations. One of these equations, linear equations, is. So what they're sort of trying to get you to do is realize that you can actually go backwards. So I could work out all these equations by just like writing it out. So the first one could be 2x plus y equals 3, and then there would have been the other one, which would have been -3y plus z equals 2. And this last one I could get, which would be -x plus 2z, because there's no y's in that one, equals -6. So you just got to go and find, is any one of them one of the solutions, because it says which one of these. And I believe, is there, which one? I can't even see it now. 2x, where is it? This one? Yeah, that one was there. Okay, so there's one of the equations. All right, the question below. The 4 matrix equation below each represents a set of simultaneous linear equations. The number of these simultaneous equations that have a unique solution. So remember, if we see unique, just write, well, unique means that the det does not equal 0. So we'll work out the determinant of all of the individuals. So if I look at this one, its determinant would be 6 times 1 minus 3 times 2. So that will be 6 minus 6, which would be 0. So does this one have a unique solution? No, it doesn't. So let's look at this one here. If I was working out the determinant, it would be 2 times -1 minus 1 times -2. So that would be -2 minus a -2, which actually becomes a plus. So that one's 0, 2. So that one has no unique solution. Let's look at this one here. Its determinant would be, just do it here, 3 times 4 minus 6 times 2. So that'd be 12 minus 12. So that equals 0. So that one doesn't have one either. And our last one over here would be 1 times 1 minus 1 times 1. And that one also equals 0. So none of these have a unique solution. So how many of these have a unique solution? None of them do. So that would be A there. All right, let's go. All right, I've taken this from a short answer to see how, in exam 2 you get questions. I honestly think exam 1 is harder, multiple choice. That's my opinion, but let's have a look. So basketball coach has written 3 linear equations which can be used to predict the number of points, rebounds, assists, and that Oscar has made in the next game. So here are the equations. It says these equations can be written equivalently in matrix form. Complete them for the following. So what you need. Oh, can you tell Dad to stop? What you need to do is write the setup of the matrices. So we've got 1, 1, and 1 because there'd be a 1 here. And then we've got 2, -1. Just remember that's a -1. 3 and 1, 2, and 1. So that's when I told you they'll sometimes ask you to do the setup. So I've done the setup. And then they've said the matrix can be solved using the following. So if you look here, they've put it in, but X is missing. But this matrix here is the inverse of that. So they've actually typed that into the calculator. So we'll go do that on the calculator to show you, and we'll be able to work out what X is. So I'll do it on my computer. So we've typed the inverse into the calculator, and we can see that X is actually a -5. So what you found, so then it says how many rebounds is Oscar predicted to pay in the next game. So you've got to remember this whole thing was working out how many points, rebounds, and assists he has. So you actually have to solve it, and you only want what you pretty much just want what the R is. So I'll go back to the calculator. So it'll be the inverse times the matrix. So when we solved this, we got 19, 10, and 4. So that means he got 19 points, 10 rebounds, and 4 assists. So how many rebounds did he get? Just write number 10. So that's what they're looking at. So it's pretty straightforward question. My calculator's dying. So which of the following systems of linear equations best represents the matrix equation?
What was the answer to
So with this question, they're just asking us to make the equations again. It's just like that one before, actually. So it is, we just write the letters out. So the first equation would have been 2v plus 2w minus 2y equals 2. 2v minus 2x equals 6, because that's all that one is. This one is 2w minus 2y equals -8, and 2v plus 2w minus 2x equals 4. So I've written them out. So remember that the order is the same. So this would be the v's, the w, the x, and the y's. And that's how it was. So can anyone see that answer there? All right, so we've got the answer B. All right, so let's just do this last one. Question 5. Liam cycles, runs, swims, and walks for exercise several times a month. So with cycles are going to be C, run is R, swim is S, and walk is W. So that's pretty much what that says. The number of times he did those activities over the 4-month and total distance is given, are shown below. All right, so the matrix that contains the distance each time he cycled, ran, swim, or walked is this. So you don't know how far he went. You're not sure, okay? So you want to work that out. So if you think about it, you have, say this first question here, say along here, he would have run, he cycled so many kilometers, which is what we're trying to find. Then he ran 7 times, and he ran that certain distance, and then swim, and then walk, and the total that was 8 walk. Oh God. 6x plus 8w, and that equals the 160. So you can see you're setting up, that would be like setting up a simultaneous equation. So the next one would be 8c plus 6r plus 9s plus 7w and equals 172. So they want you to solve. So if I set this up as a simultaneous equations, we would have, it's pretty much these numbers in there. Then I'm just going to type it in here, and then it would be C R S W, and it equals this last one. So what I can do is go do that on the calculator, and I would just solve it simultaneously, which means I'm going to have to raise this one to the power of 1 and times it by the end one. So I'll do this on the calculator, and then I'll pop the screen dump in here. Okay, so we've pressed and we got the answer of 8, 6, 1 and 9. So 8, 6, 1 and 9, there you go, it's B. All right.